Good day! I'm back! Because this day, we are going to have another type of factoring. The difference of two squares. Okay? So let us have the first example. X squared minus 9. But before we proceed with factoring, let us have the characteristic of difference of two squares. It is called difference because you will see or you will always see the negative sign or minus sign here on the middle of the two terms. Of two squares means that the first term and the second term or the two terms of the given binomials are both perfect squares. Okay? So let's now proceed with the factoring. It is very easy on how you are going to factor the difference of two squares, especially if you already have your knowledge in finding the square roots. Okay? So let us have the factors of x squared minus 9. First, you have to extract or get the square root of x squared or the first term, the x squared. And then, so you have here the square root of x squared is x. And then, we also have here another x so that you can have x times x is x squared also. And then, you have to get the square root of the second term. And then, we have here 3. The square root of 9 is 3. So, that's why you have here 3 and you have here 3. Or to check, we have 3 times 3 is 9. But, since we have here negative sign, so we have here to express our answer as the product, like this, of the sum and difference of two terms. Okay? So again, we have to express the factors of difference of two squares as the product of the sum and difference of two terms. And again, find the square root of the first term. So we have here x. Find the square root of the second term. We have here 3. Then express it as the product of the sum and difference of two terms. So, we have here the factor form of x squared minus 9 will be x plus 3 times x minus 3. Is there any question? Okay, so let's now proceed with the second example. This time, we have the numerical coefficient on the first term. We have here 4x squared minus 25. So just like what we have done on the first example, get the square root of 4x squared. So we have here 2x. Get the square root of the second term, 25. So we have here 5. And then, we also have here another 2x and another 5. And then we have here to express again the factors as the product of the sum and difference of two terms. Okay? So it's very easy. Is there any question? Okay, next. Let us have this one. Oh, it seems that both terms of the given binomial has different variables. So this time, still, you have to get the square root of the first term, 9x squared, then square root of the second term, 49y squared, and then express as the product of the sum and difference of two terms. So that's why you will have here 3x is the square root of 9x squared, and then 49y squared, the square root of it is 7y. And then we have here again the product of the sum and the difference of two terms. Okay. Any question? Okay, so let's proceed with the last example. We have 28x cubed minus 7x. Oh, it seems that the first term is not a perfect square. And also with the second term. But a while ago, I have told you that for you to make sure that the given is an example of difference of two squares, you have to take note that the term should have negative sign or minus sign between the two terms. And make sure that the first term and the second term are perfect squares. So what are we going to do with this? Okay, correct. You are going to apply what you have learned on the first type of factoring, wherein you are going to apply factoring polynomials with greatest common monomial factor. So you are going to find first for the common factor of this. Okay? What is the common factor of 28x cubed minus 7x? Okay, very good. It seems that you really understood our first type of factoring polynomials with greatest common monomial factor. Correct. So we have here the common factor, So we have here the common factor which is 7x. That's correct. So therefore, you will obtain the second factor by division. So we have 28x cubed divided by 7x is equal to, correct, we have 4x squared. Then, we have the second term, negative 7x divided by positive 7x is equal to, correct, we have negative 1. Okay. So, as you have noticed, the second factor or the quotient or the polynomial factor is still factorable. And this is under the difference of two squares. You can notice that 4x squared is a perfect square and 1 is also a perfect square. So therefore, you may now apply what we have done on the first three examples. And you will just copy the first factor or the GCMF. So you will have here 7x times the square root of 4x squared is 2x. The square root of 1 is 1. Then we have here to enclose in parentheses and express this as the product of the sum and difference like this of two terms. Therefore, the complete factors of 28x cubed minus 7x will be 7x times 2x plus 1 times 2x minus 1. Okay? Is that clear? Okay. So, that's all for this day. And you may see or you may visit your Google Classroom for your learning tasks. Bye!